All right, yeah, so this is ZFS Realistically. All right, we're all good to go.
I don't know how many of you listen to Michael Dominic's show, but I've been listening that long. Okay, I always start off with collecting your interests and your questions about the topic. And so I'll begin with the question, I know one of you, two of you already use ZFS in a daily manner. How many else of you are familiar with it or have used it?
Kind of.
Oh, wow.
I wrote
okay.
a Boxbot cluster and it's got ZFS. So.
Oh, well, that's really encouraging. Okay, that's great. Very good. Oh, yeah? Hey, with that first steps. Okay, so are any of these...
Is 100.
So is ZFS a good choice for a home lab? Do we want to begin with that question? Does anyone wonder if that's true or false, or?
Sure. It's a good question.
Well, it's a more specific question. What is ZFS?
Okay. So half of you know that answer. Right. Yeah, but that's a, here we go. So ZFS is a disk and volume management system that stripes over a combination of either mirrored VDEVs, which is a group of mirrors, a group of RAID, or a group of RAID 6. So that means that while you don't have the infinite potential of putting your disks together in any kind of super clever way, this keeps it simple and performant and redundant at the same time. So, whereas LVM, Logical Volume Manager, usually is oriented towards a more difficult manner of doing this. This allows you to set up all your disks, have all that space available all up front, and as you create file systems, then you start to begin to use your space. Whereas in logical LVM, at least 10 years ago, you had to create a fixed size partition less than what your pool size was, and then use the remainder of that unallocated space for the difference for your snapshots, which meant you couldn't just create a whole disk LVM and then you were stranded for snapshots because you had no disk space left to copy them off to. So ZFS has file systems, and a file system is more than just a directory. They can be independently snapshotted. They have independent settings like record size, how they deal with their extended attributes, and how they, and a bunch of other parameters that you can set for them. And the magical part is that you can send individual file systems to other ZFS hosts across the network. So that's your built-in backup streaming. Snapshots are a read-only image of a file system. A clone is when you have a snapshot that's actually really useful, but you want to restore it to like a read-write state for a different task. You can promote it as a clone and have a new read-write file system with it's back-ended by the snapshot.
Cloning is also an excellent way to create new VMs too. You could have a file system that just represents your default empty installation, and clone will copy, clone another copy, and you've got now 3 different VMs that you can launch.
That's an excellent use case. Thank you, Jim. Sending and receiving are the terms for sending a file system and receiving a file system. Here we go. So VDEVs, disk mirror or RAID group. RAID Z is 3 disks with the size of 2 disks, just like RAID 5. without the RAID hole. Some people might know, I'll be familiar with that. RAID Z2 is 4 disks with the size of 2 disks, that's RAID 6, so you have 2 parity drives. And a mirror is, of course, 2 or more disks with the size of 1 disk. Does anyone not considered this before? Like in terms of like their regular light sysadmin reading? Because if you haven't, we can go into it. But if these are all relatively familiar terms, we can move on.
Do you have the possibility of RAID 3 disk 1? You RAID, I can't remember the number.
C3. Like, I think he said like,
Instead of
like-
2 disks in redundancy, you get 3.
Yeah.
Yes, you can also do that.
Okay. So I mean, it's possible, just not common.
Well, if you have a pool of 60 disks, so yeah, you might probably want that. Or a pool of 120 disks or something. However, like very large VDOVs are not a good idea in terms of recovery, because you have the same possibly long-running resilvering time. In ZFS, unlike a RAID hardware system, that will stay online and it will just do the live checksumming for you. But if you were to try and resilver something with an LSI Mega RAID card, it could take you days if you're lucky. The larger the pool, weeks.
Also, the resilvering, ZFS is, where RAID would probably resilver the whole disk, because RAID doesn't know what part of the disk is used and what part of it isn't.
Yeah.
ZFS does, though, so it will only resilver the data that's actually used on the disk, and so the more compact your VDIV is, the faster it will resilver.
Okay. Unlike ZFS, ZFS offers compression. You probably don't want maximal compression because that would dominate your CPU. The place where it is renowned for its speed is that it's nearly instant snapshotting, and it's very efficient file system sending logic. Whereas if you were to take a terabyte of small files and rsync them, you could be waiting for days. With ZFS, it marshals, and in fact, if you're just doing snapshots, so the difference of them, it marshals only the changed blocks and ships the difference across the network. So it's a super, super fast way of sending your incremental snapshots across the network, or even the full, do a full send. Well, okay, so affordability, you don't have to pay for it, but you do you're gonna pay time to learn, but that's the same as any technology. Well, you can have tens of thousands or hundreds of thousands of snapshots. They do take disk space. And if nothing changes, they take metadata space. And so you can actually run your system out of space just by creating, say, 200,000 snapshots or something like that. So you have to have a way of regularly pruning your snapshots. So there's utilities that allow you to do yearly, monthly, weekly, daily, hourly kinds of father, grandfather, son kind of rotations. So you end up with only the most useful snapshots. Of course, ZFS brags about its redundancy, but beginners very likely can get around the redundancy by accident. So if you just want to add one disk, you can have like 16 disks all arranged, plug in that 17th disk, and you attach it. Now you have striped across whatever VDEVs you have, plus one disk. Now you have a single point of failure. So, goes back to time to learn. So, that we'll get to how we expand soon. And because it's got built-in checksumming, we've got bit rot resistance. Notably, one of the only other file systems with built-in checksumming is,
Butterflies.
yes. Part of the plan is working with what you can afford. And a lot of call-ins on radio, like tech radio shows, podcasts are, how do I do things like, how do I expand, I can only afford a single drive to expand my ZFS. Well, how do you do it? So this is where we have to develop a plan on how you want to use ZFS for more than a weekend. So it comes down to planning. So how cheap, like what's your budget? Are you restricted with just what old drives you have on hand? When you say you want a fast file system, fast in what way? Do you want fast writes? Do you want fast reads? What does fast mean? Do you need 10 gigabit send across the network? Do you need to save space? Do you want to use high compression and have a possibly CPU bound system? And do you want to put a database on it? What are your expectations for database IOPS? Because big databases, databases come in all shapes and sizes. So the growth plan is, are you trying to expand by drive or by VDEV? How many drives can you buy at a time if you either have to grow or replace small drives with big drives? Do you want to get a bigger chassis that you slowly expand over time? And is this the backup target, or do you have a backup target for whatever this fancy workstation or server is? And how many drives do you want to put into it so that you can actually do sends or receives at network native speeds? Because if you just have like a pair of mirrors and you have a 10 gigabit network interface, you're not going to achieve 10 gigabits on that. So, like, you're going to want more spindles to keep up with your network speed, possibly. And once again, do you have a policy for your snapshot depth? Because if you have policies around what your retention time frame is, you might want to plan bigger to accommodate your retention duration. And so that might mean bigger drives, more drives. That has an effect on cost. Some people who feel like ZFS is not for them claim that XFS is really what they're looking for because it has microsecond transaction times for writes, great for like 4K sector changes for high-speed OLTP databases. XFS is really fast, has no built-in redundancy. You have to manage that the way you would normally manage any other plain file system. Unraid is a bit more of a JBOD style. You can add random disks to it. You can grow it really cheap. And it comes with a GUI. However, I can't tell you anything about Unraid because I don't use it. I don't think Unraid has any checksumming. Can anyone check me on that?
Is he using ButterFS under the covers, or what is that under use?
Okay, ButterFS is something I didn't list, because I don't consider it an enterprise contender, because what happens when you break a mirror on Butter?
If you break a mirror on Butter, does it like boot in a read-only state? In a degraded?
No, it boots with one disk in write. When you reattach it, now it has two separate volumes. And it doesn't give you any warnings. It just boots up as if, hey, you added another drive. And now you have two totally distinct data sets, one of which has been more recently modified. Are there tools to merge those back together? I don't know those tools.
So unplanned self-decoupling.
Well, that's a great fancy word for it. And if you're approaching petabyte sizes and need a highly parallel workload, Ceph and Gluster. I can't speak about those either, other than one is object-based and one of them is the Red Hat standard. Stability. So a lot of stability in day-to-day operations is bounded by how your OS updates treat your kernel modules, or the version of the kernel you're running with built-in modules. So that would be Kmod style kernels. And while Ubuntu is shipping systems that will be, ZFS on root, which is bold of them. If they ship an update that somehow botches the ZFS module and grub installs that and totally loses all record of what your root pool is, booty. And that was a very hard recovery when that happened in 2210. And so what is more reliable in the Linux world is to give your OS its own drives and follow your distro's idea of a setup. That gives you recovery kernel. It gives you drives with an installation and recovery plan that has been supported by decades now, and are unlikely to confuse your drat-cut or your update init ramfs process, which is going to remember all of your UUIDs for all your partitions. And in terms of stability for like redundancy for your OS, it used to be that you would just do like an mdatom RAID and install on that for your OS. It's not so common now because installers like Anaconda and whatever else have a hard time setting up mirrors, and with all of the various methods of and updates to things like Anaconda, it's actually much more reliable to just install on one disk and mirror it later. And the easy way to do that is actually using LVM, because it's hard to retroactively mdatom an existing file system. Possible, tricky, highly error prone. And so now that you've heard my idea of keeping your data volume separate from your OS volume, of course, you're going to want to keep in mind that having spare drives always a good idea. And so if you're running a home lab and you use all of your drives and you have no spare drives now, your shopping list should have a spare drive.
Do you mean spare drives like hot standbys already installed, or you're just saying like keep something on site?
A cold drive on a shelf is fine. Yeah. If your workload demands uptime, having a hot spare in a slot, that's good planning. Not everyone does that, but if you have a healthy sized chassis, and the drives you're using are so large that you're very likely going to end up with spare slots, you could load it up with a couple of hot spares depending on what your VDEV layout is.
And it's really easy to add drives to a pool and subtract drives.
Yeah. So for ZFS, you can detach a drive out of a VDEV. It'll still run. You can yank the slot, put the new drive in, push the slot, and wait for your SATA subsystem to detect the drive. That'll show up in dmessage. Then you can use the proper commands. And I have a slide on that later. Some things to avoid. If you're a fan of the latest mainline kernels, they are typically outpacing the OpenZFS module compatibility. And you very likely want to stick with your OS's long-term support kernel. Now, there's always tension between your long-term support kernel and what your current hardware is. You buy a new fast piece of hardware, latest Italian-named EPIC chip with, latest Supermicro motherboard with NVMe slots on it, and your kernel might not get the full potential of your processor, or other minor details like that. Depending on what OS you're using, you can go to use the EL repo, so Enterprise Linux repo for Red Hat, and get more recent LTS kernels from the LTS tree, which might not have all of the distribution package and module defaults, but are still probably going to suit you perfectly fine, and yet be months or years ahead of what your LTS distro kernel is. Do you want to use the latest ZFS? Well, that's fine for a home lab. But considering as how you might need to be doing a git pull, git tag, recompile, remove all of your previous libraries from your other install, recompile it and reboot, find that you still have a missing library or the out-of-date library, scrub out all of your user local lib, z star files. You can see how doing an update can turn into a real chore. So if you have, multiple servers and multiple responsibilities, don't experiment with the latest ZFS unless it's just on a dev system, because you have better things to do.
So what would be the disadvantage other than familiarity with just using Unix? The OG operating system for ZFS. Free BSD or something like that.
Well, that depends on who you, as a sysadmin, choose to run and maintain. OpenZFS runs on Linux, Illumos, FreeBSD, and a couple of other BSDs. There might be one or two other operating systems that I'm forgetting. FreeBSD is very proud of their ZFS championing. They've maintained ZFS in their kernel, and there's still things that the FreeBSD people do that haven't made it into the OpenZFS code base. So, because this is Linux Fest,
Sure.
I don't get to talk to too many FreeBSD people. Some, but mostly not. So,
Jed, you have a question?
yes. Oh, pardon.
Just a helpful comment for people who are Linux people. System 76, supporters of Linux Fest Northwest, they've been working on Cosmic for years now. So the bad news is the current version of Pop! OS is based on Ubuntu 22.04. The good news is they've turned it into a sort of a mini rolling release. And so they update the kernel and ZFS. So you get fresh kernels and fresh ZFS in Pop! OS 22.04. So you have a 3-year-old GNOME, but we're running OpenZFS 2.3.0 with patches against kernel 6.12.10.
I was totally unaware of that, and I am charmed to hear it. I
Yeah,
get little sparkles.
It's DKMS. They did all the work for you. All you do is run apt update or whatever you want, and it builds the Linux kernel modules and everything, and you just reboot and you've got the current version of everything.
That's righteous.
Yeah.
Yeah. Okay, I'll have to give high five to Carl again. Okay, and another thing that, but ZFS en route is kind of like a 4x4 stunt car for your workstation if you're not using Ubuntu. Giving it to non-sysadmins, well, that's fine, but you're still their sysadmin at that point. So, careful giving it to your mom or your aunt or whoever. So honestly, ZFS is not supposed to be the the most speedy file system. And from the point of view of a fast OLTP, lots of small, quick updates file system, you're not going to get the ACID throughput that a different system could get. ZFS's internals are engineered around the dwell time between a write hitting the write buffer and the mechanical spinning of the drives. Now when it comes to things like NVMEs, that's a good read hit, but it's not a perfect solution. Recently there's been developments on doing supporting ODirect at the file system layer, so ZFS can stream straight back from NVMe. So, but in terms of like databases that are very fast, ZFS might not be your best choice. However, so you got to back up your database. Your database backups are going to be very likely in SQL. SQL's full white space. You can set up a Z pool with high compression and snapshotting and have excellent compression, like over 50%, almost guaranteed, for those database dumps. So it's not that it's a case of I gotta avoid ZFS. It's a case of putting ZFS where it shines compared to where, say, XFS shines. Different roles, better suited purposes. If you're a home labber, why only one computer in your home lab? You probably want to think about having 2 ZFS systems because you want to send your data to something that's a ZFS system. Also, RAID is not a backup. And this is a worthwhile tattoo for any sysadmin. And then if you start to fill up, like there's a magic number here, 80%. But when it comes time to expand, the common ways with things are, so like if you have a laptop, chances are you only have one NVMe in there. And if you have your whole home partition backed by ZFS, and you have that second computer with ZFS for your backups, it is really easy to install a new double-sized blank NVMe, install your OS, and then send your home partition, your ZFS pool for your home, back to it. Really easy. So, workstations, you might only have space for 4 drives, or if you have the monster truck size workstation case that has 9 or 10 drive slots, you can add another HBA and get an extra support for 8 drives, and you can keep adding drives. But if you want to plan around a small NAS system with like 4 bays, how do you want to start with that? If you're low on budget, you start with 2 drives, then expand. This is a choice you're going to have to make in that kind of situation where you have limited budget, but you do have a bit of small NAS hardware. Expansion with in-drive replacement, like we were talking about earlier, very good tactic to keep in mind. And that's, we're going to come back to that. Next slide. So chassis with extra drive slots are, so if you have a disk sled and you're upgrading size and you have empty slots, you can add multiple VDEVs of disks at a time. And then ZFS will continue to stripe across them. However, if you've got, say, RAID Z6, and you have 1 slot left, and you just want to add that 1 drive for the extra 12 terabytes or whatever, you can do it now. But if you're using, say, an LTS, an older ZFS release, you might not. So, as LTS is, so like I would presume like CentOS 10 now, it's going to support a more recent version of ZFS out of the box. You can do single drive expansion of RAID Z VDEVs. Replacing your drives with bigger ones, you can, depending on how many free like SATA ports you have, you can expand 1 or more at a time. So say if you have, you yank a drive or you do a ZFS detach, yank the drive, put in the bigger drive. You can do that for all the disks, and then you can run an auto expand on it, and then it will grow the whole VDEV up to the size dictated by the smallest drive. And so that allows you to do in-place replacement to grow your disk array. Yeah.
Does that command also, when you take the 1 drive and add it, your 17th hypothetical drive to your 16th?
We're talking about expanding the VDEV,
Well,
the RAID.
no, I was going to say, that one now is all by itself. Does that command say, take a 17th of all the other drives and move it here just so that it evens it back out again so it's a proper striped drive?
Yes. So if you're expanding the RAID Z by 1 disk, it will readjust all the parity. It might not move all the data, but it will focus on rebalancing the parity, I believe. Jim, do you think that's right? Because I've heard various quibbles
Are
on
we talking about when we change size of drives?
Well, no. like in a RAID Z, you can do a one drive expansion of
Yeah,
RAID
it's a
Z.
new enough feature, I haven't used it yet myself.
I haven't used it either, and it's not like I plan to, but, on the ZFS discussion mailing list, it sounds like it will recompute the parity, but it won't move the data blocks.
Is there a manual rebalance command that you can issue that would force the rebalancing of data?
That's a magic non-existing pony.
Okay.
There's a number of situations like that. How do you know, if you're changing compression from one to another, how do you re-change all the data that's already written? The
Yeah.
general answer for a lot of things like that is just, assuming you've got enough space, just do a ZFS send of the file system and receive it back as another file system that's got the new properties set on the new file system. And that
Yes.
rewriting of it, you have to transfer 4 terabytes or however big your file system is, but that's
Right.
about the only way to guarantee it, because you
Right.
have to rewrite
That also comes back to
potentially all of
the
data.
question, only one computer, so. Okay, this is a slide that's more of what I was discussing, and so if you read these later, this is good, a little more detailed slide. And yes, you touched on the magical rebalance. But that's adjacent to the point is that if you do add a drive or a VDEV, ZFS likes to try and fill all the drives equitably, so that in order to try and you have equal time retrieving from across your pool. If you add a VDEV, or if you're just running in stripe mode, then adding another blank drive, ZFS is going to spend all of its time trying to usage level everything that used to be, say, 80. It's going to focus on that one drive to get it close to 80. So you've suddenly lost all of the performance for recent writes and recent record reads, because ZFS is going to focus on balancing the storage volume back up towards 80%. So adding a single drive is okay for light workloads, or adding a single VDEV, not a great choice for your performance. So that goes back to the rebalance. In this case, chances are, if you really want to rebalance, send it all to the backup, receive it all to a fresh file system, then all the drives will be equitably used, and you'll get your performance back. At 80% capacity, ZFS kicks in its long storage search algorithms to find loose blocks, not long extensive blocks that are clearly unoccupied. So the space-saving algorithms are slower, and you will notice a slowdown when you get above 80% storage in your ZFS pool.
For folks that have monitoring systems, that's where I set my alert levels.
Yeah,
It
that's
just
a
checks every ZFS
super
pool on the
duper
system.
suggestion
If it's
from Jim.
80% or more, it sends an alert.
Yeah.
I think we look at an alarm level of 70 because you want to avoid getting there.
Sure,
Uh-huh.
yeah.
And we do that ahead of time.
Okay, so I wanted to show you guys an example of pool creation, and if you guys see the light blue on lighter blue? Okay, well, this is a more detailed slide. When you're creating a pool, you have a parameter called a shift, and it's an exponent that describes the size of the smallest record that you'll write to your physical disks. the default for most drives is 9, to the 9th is 512. Most SSDs, most consumer hardware is still using 512 sector sizes. Many enterprise drives and SSDs come with 4K sector sizes, and that's a shift 12. However, the hardware below that might just be happier and work faster with 4K loads, and especially on SSDs that have a shared heritage with enterprise controllers. So common wisdom has it that you're probably just fine jumping to A shift 12. One of the benefits of that is it shares your memory page size, and so you have a much more efficient from memory transfer to disk with the least involvement of your memory manager subsystem.
Is the trade-off there then that, like if you're writing lots of tiny files, you're not using your hardware as efficiently? Like smaller than your sector size?
It depends on how tiny. So if you're writing things that are best characterized by a multiple of 512, being not by 4K, then you probably want to use that. The amount of metadata that builds up with your record accounting with HF9, so for 512 sectors, is higher. So your storage density isn't as efficient. So you end up with more metadata the smaller your record size. Also has a memory footprint. Jim?
One other thing that can really hose the performance when you've got the, what do they call them, I forget, it's the emulated disk size, where the disk really does do 4K sectors, but it talks to the controller as though they're 512 byte sectors.
Yeah.
That is something you want to turn off. You usually have to go into the firmware of the drive and tell it, no, I want it to be native 4K, because
some hardware allows
regarding
you
this
to do
gentleman's
that.
question, it's not too much of a break, because the drive does everything in 4K blocks anyway. So even if you want just one 512 byte block, the drive is going to pull the whole 4K, because it doesn't deal in 512. It says it does, but that's not really true. So it's going to pull the whole 4K from the disk anyway.
Yeah.
Change that 512 in the middle. The problem comes when, like, the controller and the disk then write that 4K blocks back, and let's suppose ZFS hasn't been told A shift 12, it defaults to 512 bytes. Well, ZFS thinks it only wrote that one block, and so it only checksums that one block.
Oh,
and the other 7 blocks in that 4K, if there just happens to be a write error during that write, you've now lost, you've defeated your bit rot.
Oh, wow.
So you.
I had not read that
Anytime
before.
I've got 512 or 512 emulation drives, I always make sure I go into the firmware to tell it, no, just do 4K blocks only. And then A shift 12 is absolutely the right parameter there.
Right.
I was gonna say about the same thing. My understanding was that if you have emulated 512 byte sectors, but it's really 4K underneath, just set A shift 12 and you're gonna be fine, because ZFS is gonna write 4K at a time.
Mm-hmm.
And like there's the emulation layer that pretends we have 512K or 512 byte buffers, but if you're writing 4K anyway, it's just like, nope, you wrote the whole thing, it's okay.
But then you still, if you compose your partition layout in terms of 512 byte blocks, you have to make sure that you're aligned up on 4K boundaries, because if you start your block halfway through a 4K block or one, you want to make sure that you're aligned on 4K boundaries.
Many partitioning schemes start at a megabyte, so your first sector's usually aligned at your second megabyte. So that's also a 4K alignment.
Oh, you just got 2 minutes left on your talk.
Okay, so the last thing I wanted to say with this slide is, notice how I'm not using dev SDA, dev SDB, dev SDC. That's because SATA subsystems are renowned for not having a reliable mapping per SATA port per drive name. So you really want to use the serial number of the drive. And so if you go into dev disk by ID, you get links to the serial numbers of the drive. This means that you can identify the drive reliably, especially in cases where you've decided to shift some cables around, or you have replaced your OS drive because you lost an OS drive or something. This is a way safer way to arrange your data pool rather than the dev SDX naming scheme. More discussion on A-shift, emulated, record sizes, trade-offs for record size. So the difference between an A-shift for a sector size and a record is the largest contiguous strip of space that will get compressed and written at a time by ZFS. And that's currently a megabyte. And for workloads that are mostly static and compressible, 1 megabyte record sizes are great. But if you were to use a VM on one megabyte one, every time you want to change something in that megabyte, you read the megabyte, change to your 4K sector, write the megabyte. So it's not, you want to match your record size with your compression goals and your IOP goals. Any questions on that? Backups. There's some new ZFS features and a couple of resources. I'm happy to email you my slides or put them on my blog. So, we're at 30 seconds?
Something like that.
Yeah. Well, I'm glad I showed up here just in time to share my knowledge, and I'm happy Jim was here, and I'm happy Ian was here to share their knowledge. And I hope you've all learned something. I certainly have. And I hope you guys have a good rest of the fest. Yeah, my pleasure.